Hey guys, welcome to another video from Foolish Engineer. This time we'll see the design of a constant current regulator with simple circuits. So let's go for a ride. The very first thing we need to ask is, what is a constant current regulator? Well, any source which provides constant current irrespective of any change in output load or input voltage is known as constant current regulator. Let's see the basics of current and voltage. When we connect a normal voltage source, let's say a battery, to a resistor, then the current flowing through a resistor will be the division between voltage applied to it and its resistance. Well, this is nothing but the basic Ohm's law, right? So, with this logic, the constant current regulator changes its own resistance in order to give the constant output current, which may result in changing output voltage to pump the current in the load. So, when the load current is supposed to be increased, the regulator decreases its resistance, and when the load current is supposed to be decreased, the regulator increases its resistance. You know what? A transistor can provide regulated supply of current. We can use BJT or MOSFET depending upon the current and voltage requirement. So we can add a load to the transistor. We can bias a BJT to its base and a MOSFET to its gate. For now, we'll consider a BJT. Well, the regulators have internal feedback loops, and that's how every regulator provides constant voltage or current for any input voltage fluctuation. So to get that stability, we need to provide some feedback to any discrete circuit which will give the regulated supply. So we need to bias the BJT such that it gives constant current. There are multiple ways to add a feedback path to this transistor. First option to make a very cheap and easy constant regulator is to add a Zener diode and couple of resistors. We can add a Zener diode which provides constant voltage to the base of the transistor, a current limiting resistor to this Zener diode, and a resistor between ground and emitter of the transistor. This current limiting resistor provides required current to the Zener diode, and it provides voltage to the base of BJT. The output voltage of the Zener diode remains constant. This is the circuit diagram of the current regulator, and we connect a load between source and collector of the transistor. Here a very important aspect is that the voltage drop across the Zener diode and resistor connected between ground and emitter of the BJT should be the same, so that the BJT adjusts the collector current as per the requirement. Well, the output current of the circuit can be calculated by this formula, where VZ is Zener voltage, VBE is base to emitter voltage of the transistor, and RE is the resistor connected to the emitter. Well, we can design a current regulator where the load current should be 50 mA. The input voltage will be around 14 volts, and the forward voltage drop of the LED will be around 2.2 volts. Let's consider we have selected a Zener diode having Zener voltage of 6.8 volts. Now we can calculate the RE by this formula. So the value of this RE will be around 122 ohms. Now we need to calculate the value of this R. The current flowing through this resistance will be the sum of Zener current and base current of the transistor. Let's consider the HFE of the transistor is around 50. So we can calculate the base current with this formula. The base current of this transistor will be around 1 milliampere, and Zener current required to this Zener diode will be around 10 milliamperes, which we can check in the datasheet of the Zener diode. So the current flowing through this resistor will be around 11 milliamperes. So the value of this resistance will be calculated by this formula. So the R will be equal to around 655 ohms. Now the power dissipation of the circuit can be calculated as voltage drop across the components and current flowing through each of them. So the power dissipation of this resistance will be around 79 milliwatts. The power dissipation across the RE will be around 0.3 watts. The power dissipation across the LED will be around 110 milliwatts. The power dissipation across Zener diode will be around 68 milliwatts. And the power dissipation across the transistor will be around 288 milliwatts. So we'll need to select a transistor which can handle this much of power. Well, that's how we can design an easy current regulator using Zener diode and transistors. Let's see the simulation. This is our circuit diagram. This is the Zener diode, transistor, current limiting resistor, and this is RE. All values are based on the earlier calculations. Now we will simulate this. As you can see, the output current is nearly 50 milliamperes. If we change the input voltage from 14 to 18 volts, still the output current remains the same. Now, if we add one more LED in series, which means if we change the load, still the current remains 50 milliamperes. Well, this is the best and cheapest current regulator which can be designed. But there are some disadvantages of this circuit. If the temperature of the circuit changes, then there is slight change in the output current as well, because the Zener voltage changes due to temperature variation. One more disadvantage which you can see is that the voltage drop across this resistor should be equal to the voltage drop across Zener diode. So there will be considerable voltage drop across this resistor. And if you use this circuit for high current application, there will be so much of power dissipation in this circuit. So this should be limited up to small current applications only. Well, that's all about the current regulator using transistor and Zener diode. I hope you got something from this. If you haven't, you can watch the video again. Still, if you don't, you can ask your doubts in the comment box below. Hit the like button if you like this video, subscribe to my channel, and finally, thanks for watching.